Everyone. So for the minimum coins bottom up approach, we would adopt a very similar technique that we used in the minimum steps to one problem. So what we will do, as discussed in the concept video also, we will have to find the answer for every value of n, right? And for every value of n, we have multiple options. We can break down that n into multiple sub problems, right? So what we are going to do, we are going to form a array in this manner, and we are going to say, okay, what is the number of minimum coins that you would need to make a denomination as 1 or 2 or 3 or 4 or 5 or 6 or 7 or up to n, right? And starting from n equals to 0. So we also know that for n equals to 0, the answer is going to be 0. So this would form our base case. And for all other values, right, at n equals to 1, you have a coins array of 1, 7 and 15. You can pick a coin of 1, but you cannot pick these two. So you can just go to 1 minus 1, which is 0. So answer is going to be whatever is the minimum plus 1. 0 plus 1, 1. At n equal to 2, you can just go to here, because you can pick only this coin, right? So you will iterate over all possible coins, but you will pick those coins where the value is less than this. So it is going to be 1. From 2 you will end up at 1. So answer is going to be 1 plus 1, which is 2. Similarly 3 here, and similarly you have 4 here. But at n equal to 5 you will have 5. Here you will have 6. But n equal to 7, you can pick 2 coins. You can either pick 1 or you can pick 7. If you pick 7, you end up at, if you pick 1, you end up at 6. If you pick 7, you end up at 0. So clearly the answer of two sub problems is 0 and 6. Minimum is 0, so the answer is going to be 1, right? Similarly for 8, you can see the answer is going to be either you end up here or you end up here. In both cases it is 1. So the answer is going to be minimum of 1 and 1, which is 1 plus 1, it is going to be 2. Similarly so on. And at 15 you will have an option to end up at 14, and at 14 you will have an option to end up at 7. So the minimum is 1. So the answer for 14 is 2. And similarly at 15 you have two options. Either you end up at 14 or you end up at, sorry, this coin is 10, right? So you have three options. You can end up at 14, you can end up at 8, and you can end up at 5. So you can see these three states have already been computed. So for answer for 14 is 2, for answer for 8 is 2, and for 5 it is 5, right? So minimum is 2, 2 and 5. So minimum of these is 2, and you can say, okay, my answer is going to be 3. So you finally store a 3 here, right? This is what it is going to be, right? So the complexity, as we discussed, is going to be order of n. So you will need a loop to iterate over all of these, and for every state you need to make these many calls, right? In the worst case, so if there are t coins, you need to make t sub problems, right? So it is going to be order of n into t. Okay, let's see this bottom up approach now. And yeah, so what I can do, I can make a function min coins bottom up, and let me accept the same parameters here also. So this is n, and dp array, maybe we can create our own dp array here, and let's say everything is 0, right? So let's say answer is not known to us, it's going to be int max, or let's say answer is not needed, right? So we need to iterate over all states from 1 to capital N. So I take a for loop where n goes from 1, n is less than equal to n plus plus. So small n is a variable now, right? So capital N is the actual n, right? And small n is a variable that iterates over all the states. And at every state we have multiple options, right? So what we can do, we can initialize our current answer. So current answer is nothing but dp of I. We can say okay, set it as int max because we are going to find the minimum, right? Okay, so initialize the current answer as int max, which is a large number, and then we will try to find out the minimum by iterating over all possible coins. So for int t equals to 0, t less than t plus plus. So if I pick the tth coin, or let's say if I pick the ith coin, right? So I can go to a sub problem where the sub problem answer would be nothing but dp of n minus coins of I. This is going to be the answer of sub problem, but only if n minus coins of I is greater than equal to 0. Okay, so I will compute the sub problem only if this condition is true, like we did in the top down case. Now we have the sub problem answer, and then we can update our current answer, right? So okay, we can say okay, so current answer is going to be stored in dp of I. So dp of I is going to be minimum of whatever is my current answer, that is dp of I, and the sub problem answer, which is sub problem plus 1. That's it. And finally, if you come out of this loop, you can say okay, return dp of capital N. That will give you the final answer, right? So see guys, what we have done here, let me just repeat if you are not sure. So okay, you have, suppose you are filling this position N, right? And let's say this position is, let's say 12. So from 12 you can make a call on 11, you can make a call on, let's say coins are 1, 7 and 10, right? So you can make a call on 11, you can make a call on, let's say 5, and you can make a call on 2 also, right? Let's say this is 2, this is dp of 2. So whatever is the answer here, right? So you say okay, for n equals to 12, I know the answer is going to be infinity in the beginning, but if I found a coin whose denomination is less than equal to n, right? So this also means coins I is smaller than n, right? Or less than equal to n, right? If I can pick a coin whose denomination is less than n, then I will find the sub problem answer. So whatever is the answer for this particular sub problem, okay, so this is, add one more to it and update your dp of I. So this is sorry, this would be your dp of n, right? So my mistake, this would be dp of n, right? This would be also dp of n, right? Because this time I am using to iterate over the variables, right? So you will update your dp of n as minimum for all possible dp of n minus coins of I plus 1, right? So this is what we need to do, right? The same thing we are doing here. Okay, if this is minimum, take this. If this is minimum, take this. If this is minimum, take this, right? So whatever is the minimum, you just take it. So this would be dp of n, right? So yeah. Okay, so let's build the code and see. I was not declared. Yeah, this would be also dp of n, right? Okay, so build is successful. Let's run this one, and this way we will call min coins bottom up, and we won't pass the dp array now, right? N coins and t, only 3 variables. So min coins, so you can see the answer for 15 is still 3, and we have also discussed the space and time complexity of this code. So I hope you got the bottom up approach for the coins problem, and see you guys in the next part.